Hi everyone, thank you for attending this previous short video. I'm John. I will talk about how you can apply regression models to your research and demonstration it by using examples in medical science and social science. This video will first come across what a regression model can do and then demonstrate linear regression and logistic regression with 3 examples. We will have an introduction to the workshop and have a quick summary at the end. This video focuses on 2 regression models, linear regression and logistic regression. What can they do? Linear regression wants to explain the association between a numerical response variable and explanatory variables. How to do that? The linear regression model finds the best fitting equation to capture that association. Then, use the equation to numerically predict the response variable when new explanatory variables' values are available. For example, this equation explains the association between a son's height and his father's and mother's height. Logistic regression wants to explain the association between a categorical response variable and explanatory variables. It finds the best fitting equation for calculating the probability that the response variable belongs to a specific category. Then, use the equation to predict which category a new observations belongs to. For example, this equation explains the association between the probability of having heart disease and that person's age. If a person has a probability of having heart disease greater than 0.5, we predict that person has heart disease. There are 2 take-home messages for you. First, linear regression models predict a numerical response variable, while logistic regression models predict a categorical response variable. Second, both regression models want to summarize observed data into one simple equation. Suppose we want to answer a problem. How does a mother's height affect her daughter's height? After collecting data on the height of the mother and her daughter, we can visualize the data by a scatter plot. We can see that the height of a daughter is positively proportional to her mother's height. We can apply a linear regression model to the data to answer the following questions. First, is the mother's height a significant explanatory variable for predicting the variation of her daughter's height? If yes, how can we predict the daughter's height by her mother's height from an equation? Then, we should ask how well the regression model explains the association between the daughter's height and her mother's height. How much variability can be captured by the model? R-square or adjusted R-square are used to measure this. Let's explain some jargon in layman's language. Whenever we say an explanatory variable is significant, we strongly believe its effect on the response variable differs from 0. However, it does not necessarily mean the effect is very big. We can interpret R-squared as the explanatory variable explaining R-squared times 100% of the total variation of the response variable. R-squared measures the goodness of fit of the regression model. The following graphs can briefly show the association between R-squared and the goodness of fit of the model. After attending the workshop, you can answer this question. We first found out that the mother's height is a significant explanatory variable. We found out that this equation can capture the daughter's height. However, only 24% of the variability in the daughter's height can be explained by her mother's height. This conclusion makes sense since many factors related to the daughter's height are omitted. Then, An example from medical research used linear regression to predict the total surgical procedure time using the following explanatory variables: asphyxia control time, patient's age, physical stage of patient, estimate surgery control time, and type of operation. The total surgical procedure time is the sum of asphyxia control time and actual surgery control time. They found out that all of explanatory variables are significant. Also, using only the type of operation and estimated surgery control time as explanatory variable can already explain 84.83% of the variability of the total surgical procedure time. However, using all the explanatory variable only explain 84.99% of the total surgical procedure time variability. There are some take-home message for you. First, a significant explanatory variable does not necessarily improve the model's goodness of fit by a lot. Second, we prefer simpler models in regression model selection, and we will talk more about the model selection in the workshop. Third, a linear regression model can predict a response variable using both numerical and categorical data. Then, we use an example from social science to demonstrate logistic regression model. Suppose we want to explore the relationship between age and owning own home. We quote a person owns a home by 1, and a person does not own a home with 0. After collecting the data from 100 individuals, we have the following plot. In this scatter plot, all points fell on one of two parallel lines representing whether a person owns a home or does not own a home. We can apply a logistic regression model to this data to answer the following questions. First, is age a significant explanatory variable for predicting whether a person owns their own home? Second, if a person's age is given, how can we predict whether a person owns a home or not using an equation? After attending this workshop, you can answer the above questions. First, age is a significant explanatory variable. This equation can express the probability of a person owning their own home. If the calculated probability is greater than 0.5, we predict that person owns a home. And if the calculated probability is less than 0.5, we predict that person does not own a home. For example, for a person of 30 years old, the probability of that person owning a home is 0.13. Therefore, we predict that person does not own a home. We can visualize the equation by grouping data into different age groups with a similar size. We calculate the probability of owning own home in that age group. And we can see that our equation can approximately describe the probability. In the workshop, you will understand the framework and assumption for linear and logistic regression. Apply linear and logistic models practically to solve real research or real-life problems. Lastly, we will learn about the meaning of some statistical terms. In a nutshell, after you have collected a big data set, a regression model aims to find the association between a response variable and explanatory variable via a model that is the best fitting, simple, and easy to interpret. There is a warning for you. Association merely means that knowing the value of one variable provides information about the value of the other. And it does not necessarily imply that one caused the other. Therefore, a conclusion related to the causal relation between response variable and explanatory variable cannot be drawn based on the regression model. If your research will focus in exploring causation between two events, you should attend the workshop about statistical causal inference. Thank you for attending this previous short video. I am looking forward to seeing you in the workshop.